Good morning everyone, and thank you for joining this webinar, Flexitricity Footroom, Earn Revenue and Support Renewables. My name is Stuart Duncan and I'm the Sales Manager here at Flexitricity. Through this session, we aim to highlight the opportunity for small generators and industrial loads to generate revenue using Flexitricity's new negative reserve service, Footroom. This is our latest demand response service designed to make use of excess wind-generated energy when national electricity demand is low. The presentation will take approximately 30 minutes and we will open the floor to Q&A at the end. In addition, we will also provide a copy of the slides from today to all participants following the session. So what I'd like to do now is hand over to Dr. Alistair Martin, our Chief Strategy Officer and Founder, who will take you through today's presentation. Over to you, Alistair.
Hi, thanks Stuart. So the first thing I need to do in this presentation is to explain the name, how we came up with the name Footroom. Well, we didn't. It's a National Grid nickname, and it comes from something that National Grid has been doing for many years, as have we. And that word that they used in the past and still use now is Headroom, otherwise known as positive reserve. Headroom is the space to turn things up, to turn generators up and to turn load down when the national electricity system hits the problem. So that could be a power station failure, or it could be a demand peak, or anything like that. We're known for Headroom. We're known for turning generation up and turning load down during periods of stress. Footroom is the opposite of that. Footroom means providing space to turn things down, to turn generation down when there's too much generation. And we now have the first ever demand-side Footroom contract. We negotiated that with National Grid. It's never been done before, and obviously that means we're very excited by it, but that's where the word came from. Okay, so why is it required? This very, very simple explanation, there's far more to it than this, but the simple explanation is that we have very roughly about 10 gigawatts of wind power in the GB national system now, and you know, depending on closure dates and the dates for new commissioning, roughly 10 gigawatts of nuclear. Summer minimum demand, which occurs is likely to occur on a Sunday at 5 a.m. in July, is about 19 gigawatts. But of course, it hits low points throughout the year, and clearly that means there's more generation on wind and nuclear than is required to meet summer minimum demand. But on top of that, it's necessary for the system to hold flexible plant, controllable flexible plant, which, apart from the positive reserve that we provide, comes from large coal and gas power stations. And they need to hold that even when they have wind and nuclear going at full pelt. And this is not an issue that is shrinking because wind is growing. I apologize that this slide is probably slightly out of date. Most of the under construction wind farms there in the sort of reddish purple are probably now built, and we're probably chewing our way through the consented and planning wind farms now. What this slide tells us is that the total volume of wind that we could connect in GB is greater not just than summer minimum demand, but greater than winter maximum demand. Clearly, if we get any distance through the offshore wind sites, the system is going to operate in a very different way to the way that it operates now. And that will mean that the service that we're creating now will essentially be the vanguard of something quite a lot larger. But where we are is where we are, and what we find is that as of today, Footroom exists in two main forms. What I've described is essentially the energy balancing conundrum. It's making sure that we have enough ability to turn things down. Breaking that down into some slightly more detailed form, nuclear tends to be inflexible. Surprisingly, to those outside the hydro industry, hydro tends to be inflexible as well, and that's historical, and it's also to do with environmental constraints imposed on cascade hydro systems. So that's about 11 gigawatts of plant that really very often finds itself in must-run conditions. A thermal plant is required for frequency response for other forms of headroom, including short-term operating reserve, and it's also required if minimum demand is at night. Well, the night finishes abruptly at 7 a.m. with a sudden ramp up in demand. The morning pickup requires controllable generation. And finally, voltage regulation in the transmission network has increasingly been an important part of what thermal plant have to do. So you can't turn off all of the coal and gas generators in order to make space for nuclear and wind. Not only that, but you can't turn them all down to zero in order to ramp them up, because they all have something called a stable export limit. They don't like generating below a certain level. So if you have a 500 megawatt gas plant, that plant may be unwilling to generate below 200 megawatts or something like that. So that's the energy balancing side, and that's where you're talking about balancing energy in the national system, regardless of its location. Energy flows or transmission constraints or whatever is where it becomes regional and locational. Generally speaking, wind resources are not close to demand centres. The centres of demand, the centre of gravity of demand is in southeast England, and the centre of gravity of wind generation is either offshore or it's in northwest Scotland, and that requires transmission. It's also necessary for the transmission network to be secure, and that requires double circuit security, which means that if one circuit fails, another circuit can carry the whole of the load that's flowing down that leg of transmission at that time. And that means that often you have far less transmission capacity than you think you do. On top of that, outages occur. There's a major outage going on right now in Scotland, but in fact there are two, and these are restricting the ability of the transmission network to transmit wind power south. And outages happen all the time. They're planned, and they're typically planned for the summer, because the summer is not the period of peak demand. But that's when the Footroom events become significant. Okay, so two forms of Footroom. Another view of the same thing. Actually, the two forms have tended to break down quite neatly. What you see here are the wind farms that have received Footroom events. These are wind farms that have been paid to turn off. The red ones are all onshore, and they're all in Scotland. The blue ones are all offshore, and they're all around the coast of England. And they have been accessed by National Grid for a variety of reasons, including non-geographical, including voltage management, especially in the southeast, and including transmission constraints. Generally speaking, the offshore wind farms are accessed at higher prices and less frequently, whereas the red ones, the onshore wind farms, are accessed more frequently and at lower prices.